For the afternoon session of the Climate Change Impacts and Adaptation. Very excited to continue from this morning. We had a great session this morning. We'll have 4 talks this afternoon, followed by a panel with our speakers. Our first speaker is Faith Ochwada-Doyle, who I'm very excited to welcome.
Perfect. Thank you so much, and thanks for coming, guys, on this last conference day. I'm Faith, as you've just heard, and I'll be presenting the findings of some recent research which quantified the interannual changes in the New South Wales recreational fishery. The study mainly looks at how these changes happened in relation to a series of extreme climate-related events and COVID-19. Now, as we've seen in many of the presentations given here, fisheries are temporally dynamic and can change through time in a number of ways. For recreational fisheries, temporal variation can occur in response to environmental changes that affect either ecological processes or those that alter the behaviours and decision-making of fishes. This is because recreational fisheries represent a quintessential socio-ecological system, simply meaning that they are linked systems of people and nature, a concept that was first very well illustrated by Len Hunt, but also eloquently described earlier today in Beth's plenary and a few other talks, including Holly's this morning. The rec fishery socio-ecological system can be affected by environmental change through 3 pathways. Pathway 1 involves environmental change that impacts environmental conditions and thus fish ecology, which then influences fishes and their fishing experience. Pathway 2 involves environmental conditions that influence fishes directly. And finally, Pathway 3 considers how policies aimed at mitigating against or adapting to environmental change can influence the fishes. Now, it goes without saying that some of the environmental changes caused by climatic variation will continue to impact recreational fisheries. And we've seen some great examples of this during the conference, including Paul Venturelli's talk. We saw it in Sasha's plenary and plenty of others. In freshwater ecosystems, climate change is estimated to threaten approximately 50% of fish species by directly altering species distributions and survival rates. Climate change will also likely intensify the impacts and frequency of localised extreme weather events such as droughts, storms, floods, and wildfires. Now, among these extreme weather events, scientists generally have greater confidence in attributing events such as extreme heat and cold at the top there, droughts, and to a lesser extent, extreme rainfall to human-induced climate change. It is these particular events that can have the greatest impacts on freshwater ecosystems and their services. Recent droughts, for instance, caused significant declines in the levels of the Rhine River in Germany, and here in Australia, that also occurred in places like the Darling River. Now, although several international studies have documented changes in recreational fisheries in relation to extreme weather events, Australian studies examining such variation in freshwater ecosystems remain relatively limited. Environmental changes often take place over a changing socio-economic and political landscape, and societal changes can affect fisher behaviour and decision-making. The emergence of the COVID-19 pandemic, for example, which itself was linked to human-induced environmental changes such as urban sprawl and climate change, was an atypical event that caused rapid changes to economies and societies. It modified human behaviour through restrictions to gatherings as well as local and international movement. So the pandemic ended up affecting human access and use of aquatic systems and was shown to affect the distribution of recreational fishing in many Australian marine systems. As we heard in one of Andy Danilchuk's talks, in some parts of the states, rec fishing was in fact referred to as the the sport of the pandemic. Just like the impacts of extreme weather events, however, changes in freshwater recreational fishing have not been widely tracked in Australia in relation to the societal changes brought about by COVID. Now, in the Australian jurisdictions of New South Wales and the ACT, standardised off-site surveys are routinely used to monitor temporal patterns in the fishing activity of rec licensed households. This is done across all geographic strata within these jurisdictions, as well as neighbouring jurisdictions. The freshwater bodies of New South Wales and ACT are primarily rec only, making these surveys a vital fisheries monitoring tool. Our surveys were first used in 2013-14 and have since been, sorry, I think I've gone too far, and have since been completed for 2017-18 and 2019-20, I think. Yeah. These last two survey years not only covered the period when COVID-19 spread through New South Wales and ACT, they also coincided with a series of extreme weather events within the region. These events were the most severe drought recorded in the European history of Australia, the Black Summer bushfires, which burned through more land than any fires in the last 25 years, and heavy rainfall and subsequent flooding that led to some of the highest river levels since 1992. This synchronicity in fishery data collection and the extreme events created a unique study opportunity. So to try and understand how these types of events shape the recreational sector, our study quantified changes in the total fishing effort and the catch of key finfish between 2013-14, 2017-18 and 2019-20. Now, in an earlier slide, I touched on this concept of attribution with respect to the ability of science to attribute particular events to human-induced climate change. Similarly here, it's really important to acknowledge that from this opportunistic study, we cannot unequivocally infer a causal relationship between patterns of recreational fishing and the atypical events in question. So for each statewide survey that we ran, a sample was drawn from the 1 to 3 year recreational fishing licence database. This was done using stratified random sampling, which involves dividing our population up into geographic strata and drawing a separate probability sample from each of those strata. Our primary sampling units were the households of the selected licence holders, and we collected information on fishing activity for all anglers within the household, which includes not only the primary licence holder, but also other exempt fishers and short-term licensed anglers within that household. Now, the chart I'll take you through next really shows the different components of the survey design. As mentioned, the gross random sample was drawn from the RFL database. The survey methodology then essentially involved a multi-phase design whereby the survey's main engine was made up of two parts. First, there was the screening phase to gather profiling information from the gross random sample that responded to our initial screening calls. And then there was a diary phase conducted on the screening survey respondents that indicated an intention to fish during the ensuing 12 months. Phase 2 was effectively a longitudinal panel survey in which respondents provided detailed catch and effort information to trained interviewers on at least a monthly basis. A smaller third survey phase conducted at the end of the year allowed us to collect and evaluate social and attitudinal information. This phase also enabled us estimation of the proportion of unexpected influx anglers back into the recreational fishery, and therefore provided some symmetry for those that were part of an unexpected outflux from the fishery. At each survey's conclusion, information collected from each sampled household was expanded to population estimates. This process relies on an integrated approach that calibrates against population benchmarks and adjust for non-response using logistic general linear models. Generalised linear mixed effects models, assuming a negative binomial distribution, were then used to examine whether species-specific catch, total catch and effort changed among those 3 survey years. The use of generalised linear mixed effects models really enabled us to account for any non-independence among primary sampling units through inclusion of random effects terms for individual persons and households. The models took on the general form shown here and tested the null hypothesis that the regression coefficient for year was equal to 0. Now, the mixed effects models showed that year had a statistically significant effect on total effort. Effort was highest in 13-14 and similarly low in 17-18 and 19-20. Both species-specific and total catch across 5 key finfish species was examined. These species were the native Murray cod, golden perch and Australian bass, as well as the introduced brown and rainbow trout. The relationship between year and retained catch varied among the 5 species. Retained catches of Australian bass, brown trout and Murray cod were relatively static through the years. But the retained catch of golden perch was highest in 13-14 and lowest in 19-20, whereas that of rainbow trout was highest in 13-14 and 17-18 and then dropped in 19-20. Total retained catch across these 5 species did not change between 13-14 and 17-18, but then dropped significantly by 19-20. The relationship between year and released catch also varied among the 5 species. Released catch numbers of Australian bass and brown trout were static, whilst those of golden perch, Murray cod and rainbow trout showed different types of significant differences there. Total released catch across the 5 species was highest in 17-18, then 13-14 and dropped even further by 19-20. Now, as a conclusion, the ecologist in me would love to speculate about all the ecological processes driving the fishery patterns just described. However, I'm clearly limited by the fact that we can't really draw definitive conclusions about causal relationships here. Even so, I'll indulge for just 1 second by focusing on our golden perch findings. The combination of elevated temperatures, low oxygen and increased stratification during the drought of 18-19 are thought to have caused hypoxia, leading to fish kill events from millions of native fish, including golden perch. Following the drought period, the bushfires were a second step in a cascade of events that modified the biogeochemistry of freshwater systems. The heavy rainfall and flooding that then occurred deteriorated water quality further, possibly compounding the effects of the fish kill events by limiting golden perch recruitment. I'll end with some preliminary saltwater data collected during our surveys. Here we find evidence suggesting that the cascade of extreme weather events may have influenced fishing activity for some but not all species in estuarine and oceanic environments. Keep in mind that our marine rec fisheries are much larger than our freshwater ones, enabling greater resolution to examine core spatial differences over the 3 years. If you recall, those black summer bushfires and the floods both occurred in 1920. Now, although the north coast was flood affected, the south coast was hit much harder by both of these extreme events, as you can see here from the fires. Looking at bream and snapper, which are commonly caught in estuarine and oceanic waters, for bream, we see a drop in terms of total catch in the south coast during 1920. And that's a reduction that's clearly not commensurate with what we saw in the north and central coast regions. For snapper, however, we don't see the same spatiotemporal relationship. In fact, catch pulled across bioregions for snapper was similar among the years. And I'll skip over the effort results to get to the end, but in a nutshell, I think this study clearly demonstrates the utility of off-site surveys in monitoring fishery variation, and for me it clearly illustrates how rec fisheries can be governed by a unique complex of socio-ecological factors.
Thank you so much, Faith. I want to welcome our next speaker, Warren Potts, who will be talking more.
Right, afternoon everyone. I'm really excited to give this talk because it's a culmination of 2 consecutive projects and 3 PhD and 3 MSc studies. So I'm trying to put it all together into 15 minutes, and I hope it is somewhat coherent. So let's give it a go. Okay, so we all know that angling selectively removes certain individuals, and this has potentially major consequences for fish populations. An example of that would be removing fish with fast growth rates, which has been shown, and that can result in slower population growth rates, so known as the Rosalie phenomenon. We also know that bold individuals are often removed by angling, which leaves a population more timid, and that was shown by Robert Arlinghouse et al. And ultimately, angling reduces diversity in fish populations. Now, how does this link to climate change? Well, if you consider that there's a link between the growth and physiology of fishes, and also a link between boldness and physiology of fishes, surely then angling should also remove certain physiological phenotypes from a fish population. So we generally use a number of physiological metrics when we're talking about climate change, but one of the metrics in particular that's useful is when we look at metabolic physiology is the idea of aerobic scope, and that's essentially the amount of energy available to fish beyond the energy needed for basic requirements. And when we are studying the likely impacts of climate on fish, we develop things called aerobic scope curves, which essentially show us how much energy available a fish has at a range of temperatures. And so we've been working with metabolic physiology of red roman for some time in South Africa now. They're a wonderful fish, incredibly resident, highly exploited by angling in the commercial and recreational sector. And they live in an extremely thermally variable environment. So if you have a look at their aerobic scope curve, you can see on the left-hand side, basically their thermal range is somewhere from around 8 degrees to 26 degrees. And this is really a product of the very variable thermal environment. And so we developed an average aerobic scope curve for the species over time. I would also like to say that the climate in the southern Cape Coast, where we work, is also changing rapidly, and we're getting warm water influence from the Agulhas current, but then also increased levels of upwelling. So we're seeing these fish pushed on their thermal extremes. So we're getting warmer waters and then interspersed with really, really rapid cooling. So the physiological stress on these fish is enormous. And while you look at a population aerobic scope curve, you think, well, that's pretty much how it looks. But then we looked at individuals within the population, and this is a study by Lauren Bailey on the right-hand side, and you can see she tracked the aerobic scope curves of individuals. In other words, she did repeated measurements on individuals, and she found an enormous individual variation that makes up that population-based aerobic scope curve, which suggests to us that there's some individuals that have got really broad physiological performance and good and really high physiological performance, and yet others that have very poor physiological performance. So the next step was to try and see whether exploited and unexploited populations had different population physiology. So we took fish from long-term unexploited marine protected areas and highly exploited areas, and we brought them back to the lab, and we essentially looked at their physiology to see if there were differences in the aerobic scope curves. And we did it for two unexploited populations and 2 exploited populations. The reason they presented separately was because they were slightly different thermal ranges, but they were, in this case, the graph on the left is for Titicaca, a very, very old marine protected area, and a very similar environment, which is very highly exploited just off Port Elizabeth. And the same for the other, different MPA and a different, but similar environmental habitat to the protected area. And what we found was there was significant differences in the aerobic scope curve between the exploited and unexploited populations. And this was an immediate concern for us. And the other thing that we noticed was this was particularly evident at thermal extremes. And that's really concerning from a climate perspective, because when we start pushing fish into their thermal extremes, it means that the ones that are exploited are less likely to be able to adapt to the kinds of changes that we see. But we really wanted to know what the mechanism was that was driving the differences. Why was angling removing these high-performance phenotypes out of exploited populations? So we went and we did a telemetry experiment in the same exploited and unexploited areas. We tagged fish with acoustic accelerometers, and then we had a look at the activity of the fish populations between the different areas. And we found, and this shouldn't really be surprising, that fish in the unexploited areas were generally more active than those in the exploited areas, and they were significantly more active, particularly at thermal extremes, which is exactly as our aerobic scope and laboratory information had predicted. So we're really seeing a big difference in the activity between exploited and unexploited fish populations. And when we looked closer at an individual level, we found that there were far fewer individuals that maintained their activity at extreme temperatures in the exploited population, which suggested the highly active fish were being removed by angling. And so our conclusion was that the mechanism behind this physiological difference is that the high thermal performance phenotypes are being selectively removed because they're susceptible to fishing at all temperatures, so right across the range, whereas the low thermal performance phenotypes are only susceptible to angling at their optimal, at really the optimal temperatures for the species. And so we're selectively removing those high performance phenotypes while we angle. Unfortunately, the consequences for that are that we're ending up with low thermal performance phenotypes, and the ones that are going to be less resilient to the impacts of climate change. We also then wanted to know whether boldness had anything to do with the way that the physiology of the fish populations were ending up. So Lauren Bailey, a PhD student of mine, tried to link physiology and boldness. And the first thing she did was she did aerobic scope curves for individuals. She separated them into what we would classify as high performance, intermediate performers, and low performers. And then we marked them with VIFE tags, and then took them into the behavioral arena and did a series of behavioral tests on these individuals, including activity tests, boldness tests, and aggression tests. And then we split them up to see what their boldness composite scores were and how they related to their physiology. And we found, and you'll see in the second figure down below, that the high performance phenotypes, which are the red bars, were all bold individuals. Okay. Now we know that they were bold across all temperatures, well, not across all temperatures, because she tested the behavior of these fish across temperatures, and she found, interestingly, that at optimal temperatures, the high thermal performance were by far the boldest, and at extreme warm temperatures, they were by far the boldest. Interestingly, the low performance phenotypes were actually bolder at the lowest temperatures, which indicates to me there's some kind of way that they adapt in that they're outcompeted at normal and high temperatures, and then some try to manage to get food at low temperatures. So it was an interesting dynamic that we noticed. We then took those fish and we put them into duels. So we took the bold and high thermal performers, bold intermediate performers, timid high performers, intermediate performers, and timid low performers, and we pitted them against each other in a behavioral arena. We put them in an arena and dropped food and went to see which one got to the food first. And essentially what we found was the bold, high performers and intermediate performers were dominant over all the low performers. So essentially it's saying that physiology and boldness are linked, and boldness is another mechanism that is affecting the way that fish populations are being selected out by angling. So essentially, angling is disproportionately removing bold individuals at optimal temperatures, as well as and the bold performers are also high performers, and then it's also moving the high performers at extreme temperatures. So we're having a double whammy of selection for those high performing phenotypes. And the end consequence is, again, we're ending up with low thermal performance fish that are now potentially the ones that are producing the next generation. But we needed to know whether those physiological performance phenotypes were actually passed on to the next generation. We weren't sure that, it was taking the next step. So we went off and we collected adults from the exploited and unexploited populations. We spawned them, took them back to the lab, and we compared their physiology. We didn't want to use temperature because the eggs and larvae have a very narrow thermal range, so we didn't want to kill them all immediately. So we used pH as a proxy for stress, and we stressed out the juveniles with low pH conditions, and we found that the larvae from the exploited populations underwent a metabolic depression very early on in their life history, which in a case of an area that didn't have a lot of food would result in likely mortality. We gave them a lot of food and they managed to recover, but the point was there was a definite passing on of the high performance genes through. And ultimately, larvae from the protected populations exhibited far greater resilience to the impacts, in this case of climate change, and that was pH. So I can conclude by saying that we need to be considering that angling is removing our fittest fish from populations. And that's a major problem, and we need to consider this in management, and we need to begin thinking about adaptation and how we can promote adaptation in our fish populations. And I think thinking of the idea of trying to preserve what I would call future performance phenotypes in fish populations is the way that we've got to start thinking. So what is a future performance phenotype? I would say that in an area like the southern Cape Coast of South Africa, it's a phenotype that has a very broad aerobic scope that can deal with the upward and downward fluctuations that you're seeing. A future performance phenotype in the tropics, for example, on the Australian east coast, would be something that performs very well at high temperatures. And we need to be thinking about preserving those phenotypes so that we maintain adaptive capacity in our fish populations. So there is hope, and we can do this. And the one way, there are a couple of ways that I'm thinking that we can do that. And for resident species, first of all, I think that a network of well-designed marine protected areas can be used to protect those future performance phenotypes. You need to understand, though, what the larval dispersal looks like. So, and ideally, you want to identify the really important fishing grounds, and you need to figure out where the eggs and larvae are coming from so that you can protect those areas so that they can seed your fishing grounds, so you've got high performance phenotypes, bold fish that are likely to feed, and you maintain your angling in those areas. So that's the one idea for resident species. For mobile species, I think we need to begin thinking about limiting angler effort during environmental extreme conditions. So marine heat waves, cooling events, we need to try and start limiting angling effort, because during those events, we know that we're removing those physiologically fit phenotypes, those ones that are going to provide us with the basic material, will provide fish with the basic material to be able to adapt to the impacts of climate change. And so, yeah, I'm really interested to hear any comments that you guys have got on what we found, but I've found it pretty interesting and hopefully will be useful. Thanks.
That is really wonderful stuff. Please join me in welcoming our next speaker, Cassie Price.
Hello again, and thank you. I think Beth and Faith both gave us a really good lead in their presentations on climate change and the climate topic for fish. And we'll be bringing you some of what that meant on the ground for our local recreational fishers and their waterways. So I'm lucky enough to have my colleague Harry Davey here with me today to help me present this. Harry's led our Ozfish movement in the Northern Basin since Ozfish's inception, and later he'll be giving you some of his first-hand experiences of climate and the climate extremes that our fish have been facing. Use this one. Okay. So there's no doubt that our fishers love our sunburnt country, but they're also at the forefront of those impacts of drought, fire and flood on their local waterways. And we're really here to show you today what they saw and what they experienced over about the last 5 years of climate extremes that we've had. But it's the actions of those local fishers that are really making the future resilience and the change that we need at a scale required to really make a difference for our waterways in the face of these events. So I'm really proud to be bringing you their story. You'll see lots of different Oz fishers in this presentation in their experiences all around the country. This doesn't like me. There we go. So cast your mind back now to the drought conditions that we experienced in 2017 to 2019. And it might seem a long time ago with the amount of water that we've had across our country recently, but really this is less than 5 years ago. Just to note that Ozfish was just commencing some of our early project operations in early 2017, and my reason for pointing that out will become apparent to you. And we had only 8 chapters established at that time, and importantly one of those was Sunraysia at Mildura, and thank goodness they were there when you see what happened next. And also Harry's chapter at Tenterfield, which will also play a key role in some of the fisher responses to these climate events. So some of the things that our fishers saw coming into late 2018 meant that it became really apparent that the drought was going to mean some immediate action would be needed by our fishers on the ground. And with these sorts of headlines, they were looking to Ozfish in our early days for some assistance and what they could do when they were seeing their wetlands turn belly up. So you'll remember the fish kills of the Darling in 2018 and those drying pools. And I want to show you some of the immediate response that we helped those fishers with during that time. There were 2 key actions that they undertook. Immediately was fish rescues and putting in some aeration, so we had some aerated pools for those fish to go to be placed in and to have refuges during this drought time. So I'm just going to play you a little video here which shows some of that activity on the ground. Bear with me. Come back. There we are.
Since late 2018, the lower Darling River has contracted to isolated pools. Many of these pools were rapidly drying, leaving native fish at risk of perishing. Concerned community members could not stand by and watch the lower Darling native fish perish. With the approval of the Department of Primary Industries Fisheries, Ozfish Unlimited volunteers contributed to a program to undertake native fish relocations during summer of 2019 to 2020. The program was supported by landowners who allowed access to remote stations on the lower Darling from Pinkeri to Batundi Station. Volunteers gave more than 1,300 hours, travelled thousands of kilometres and donated equipment to safely catch and transport native fish to prevent the deaths of hundreds of stranded fish. The volunteers worked in extreme conditions including poor water quality, knee-deep mud, steep banks and heat wave conditions to rescue and relocate precious native fish. The result of its hard work was the relocation of 320 native fish by the Ozfish team to more permanent and viable water sources. These rescued fish were in addition to efforts undertaken by New South Wales Fisheries and other recreational anglers from Broken Hill and Menindee along the lower Darling, with over 1,500 fish rescued and relocated in total. The biggest fish moved by Ozfish volunteers was a 1.26 metre long Murray cod, estimated to be more than 25 years old. With much needed flows finally set to return to the lower Darling, these fish will now survive the terrible drought and will have the opportunity in future to breed and contribute to future native fish recovery. These efforts will benefit generations of Australian fishers. This work would not have been possible without the support from New South Wales DPI Fisheries, Ozfish Unlimited, our great partner BCF and Wentworth Shire Council.
So you can see some of the great work that our fishers did there, Braden Lampard and Taylor Pay of the Sunraysia chapter, in some pretty dire conditions for our fish. Arguably, more importantly, no, I don't want that to play again. There we go. After that time, they didn't stop there. They put a whole lot of effort into making sure that they were rebuilding habitat in our rivers that were needed to speed that recovery of that fish population as those conditions eased. So now with over 350 new structures for homes for fish in our New South Wales waterways down in those areas, the future of those fish are looking much brighter. There was more bad news for the rest of our country and some other parts where our chapters were established. Just 12 months later, after facing 3 years of drought conditions, we had the catastrophic fire season hit. And it hit many of our communities, particularly in coastal New South Wales, Victoria and Queensland. Again, by late 2019, it became apparent that our waterways and our fish were in a whole lot of trouble. So while rescues generally weren't an option, some were undertaken, I think, by fisheries at that time, our fishers certainly began preparing for the recovery that they knew would be needed for these waterways. Some of the things that our fishers were seeing, again, through our waterways, they were hot, they were drying, and they were fast becoming full of ash, with eroded bank soils and a really destroyed riparian zone. So again, some devastating times for our fish straight after that drought. So we had far-reaching recovery from our fishers in response to those fires. By this time, Ozfish had about 20 odd chapters established across Australia, and many of them got involved in this recovery after fire. We actually had our groups working across 9 fire fronts in the recovery of the fire. And I'm going to pass over now to Harry because he's going to really give you a first-hand view of what happened and what was happening on the ground with those fishers during that recovery time. Thanks, Harry.
Thanks, Cass. Good afternoon, I'm Harry Davey. This is very emotional for me to be involved in this and what we have achieved over all these disasters just amazes me that we turn up time and time again. And just to give you a little rundown, I come from the northern tablelands. I live in a little town called Tenterfield. Our creek is 108 kilometres long, which feeds into the Murray-Darling Basin. And we had a fish kill down there that was 38 kilometres long as a result of after fire being flooded and having an ash, just to give you an idea. And the fires raged from Tenterfield down to Ratville and Nimboida for 9 months that year. So, what do we do in case of with all this disaster and that around us? So, a call to action was put out, and our focus was on recovery of habitat and resilience. And what we found, so we concentrated a lot of work on the Nimboida that was just devastated by fires. A couple of Ozfish members, passionate members, David Fairclough and Alicia Cockbain, the only thing they had left standing on their property was actually their building. And there were 6 properties around them completely destroyed. And so instead of sitting there wondering what we're going to do, they all banded together and we have since planted 8,000 native trees and shrubs and grasses. And what we have found is that the actual waterway, the fish are very resilient, and this is in eastern cod territory, which is a threatened species. The waterway recovered quicker than the actual land did. It was quite amazing just how the waterways recovered. Obviously, because of the area we live in, I'm in a very special area. I'm lucky enough to have the eastern cod on the eastern side in the current system because I live on the watershed, and the Murray-Darling Basin we had the southern purple-spotted gudgeon. So during those times, gudgeon were taken out of Tenterfield because we have one of the last remaining wild populations of southern purple-spotted gudgeons in the country. And they were relocated back to Grafton Hatchery with Dr. Gav Butler and his awesome team. So since that time, we have done some work on several sites in Tenterfield improving southern purple-spotted gudgeon habitat. And we're really glad to say that just last year, and I can't remember the year before's figures, but we released 2,063 of those beautiful little aggressive fish back into the waterway, involving a class at the local primary school, which was involved all year round in threatened species. and the things that we've learnt. So to motivate and to upskill our chapter members, we decided to focus on fisher science and break that fisher science down into modules where we can upskill our chapter members, understand what's happening in real time now on our waterway and over a data spread. So this has been happening from the top of the state to the bottom of the state. And I'm sorry I'm only touching on what I saw up in Northern Tablelands, and I know the South Coast was heavily impacted, but a lot of waterway fire science has gone into the South Coast, and we're now seeing results of that data being used in the projects that come up. And then we go from one extreme to another, so floods. So they began to flow from October 2020, which was the start of the fish kill. So just a simple indication, everything was burnt out at the head of Tenterfield Creek, and we had 326 millimetres in 6 hours of rain. So they saved the town because they firebombed all the top of Derry Mountain all the way along the range. It saved the town. But what it also did was it put tons and tons and tons and tons of fire retardant into our waterway. So as I said, that went for 38 kilometres long. Now, it was a very distressing time for me, seeing large Murray cod. And when I'm talking about large Murray cod, we took over 136 metre cod out of Tenterfield Dam with excavators, and it was 2 cod to a 240 litre bin. And when you're as passionate about me about those Murray cod, it was devastating. But we moved on. But what we've seen since 2020, though, is literally every month since then, on a river somewhere in Australia, there has been a flood event. Okay? We're in another ongoing crisis. And so how do we manage that? You know, our fire sites on Nimboida have had 11 floods at over 8 metres. And I'm very, very happy to say that our deep planting that we use to do that, we still have 85% recovery, 85% plants left. I'm just amazed at how resilient they can be. And they've been underwater for a long time. But a little bit about what our fishers saw. I think we've got a little video of Braden down at the Murray. You can press the button, Cass.
We've placed over 200 crayfish. These ones here are the ones with eggs. So all these ones have eggs. So these crays are currently going to be taken by New South Wales Fisheries, and they'll be dropped off to Narrandera Fisheries facilities this afternoon and placed in holding tanks.
So that was my mighty leader, Braden Lampard, who I'm very proud to call my boss, leading the way. So I was lucky enough to be put on a plane and sent down to Swan Hill and be involved in the other end of the scale. Instead of climbing up 30-metre banks in 40-degree heat, I was trying to save fish in a flood. And rescuing Murray crays, which I had never seen before in my life but knew about, and then having people come up to us on the side of the riverbank and saying, I've never seen a Murray cray, and they've lived there for 40 years. So that's a rare event. So we've seen it all. We've seen it from flouts and drought and flooding rains, and now it's starting to come back. And it's just amazing, you know, with the post-flood recovery, which is still ongoing, and I think we're going to have more events. You know, we've got to look at different ways on how we mitigate that.
Murray River.
Sorry, mate. So, yeah, so supporting our populations to recover. We've done a lot of it, especially down in the Nimboida and in the Tenterfield area, a lot of erosion control measures, which are now starting to take effect, which is seeing less sediment come back into our waterways. So those things are really important, and it's just building those habitats, and we've seen the fish come back. It's just amazing just how resilient they are. But none of this is even, you know, can be done without the sheer, you know, the partnerships that we have with Fisheries, Landcare, National Parks, Indigenous First Nations, which are heavily involved in everything we do. And I'm really proud to say that I'm wearing Michael Kirk, our cultural officer for Maori, Gomeroi hat tonight, because I wanted him to be on the world stage with me. So, thanks, guys.
Fantastic. Thank you, everyone. Thank you so much. I want to welcome our final speaker for this session today, Hui Xiao, and then we'll be following this up with a panel for time for questions with all of our speakers. So, welcome.
Hello, everyone. This is the last, but hopefully not the least. So this talk is about a literature review of travel cost studies on recreational fishery evaluation. My name is Hui. I'm currently working as a marine resource economist at CSIRO Brisbane. And this is actually a 3-year project with the general aim is to evaluate recreational fishery with state-of-the-art econometric models. And once we have the data, we're going to try to estimate the value of change of the anglers and the climate change scenarios and policy changes as well. But the first step, which is the aim of this talk here, is to present you a global overview of different travel cost approaches applied on recreational fishery evaluation. I would like to begin by acknowledging the traditional owners of the land that we're meeting on today and pay my respect to their elders past and present. So the first question is, why do we need to evaluate recreational fishery? Why do we care? So what about think about your next holiday activities? What are you going to do for your next holiday? Bushwalking, snorkeling, fishing, swimming, or just relax on the beach watching your kids playing around? So all those types of activities have a common name, the recreational activities or recreational services that you receive from nature. And those activities are important to your well-being because you would feel recharged in connection with nature. However, do you know how much they're worth to you? For example, as an angler, are you willing to receive $100 a year with a closure of your favorite fishing sites? Are you willing to pay $100 a year in order to access to a new fishing spot where you can catch more of your favorite fish species? Without knowing how much that recreational fishing activity worth to you, it is hard for both you as an individual and for decision makers to make decisions, for example, between a closure of a fishing site for a new protected area or keep that site open, considering the benefits of the anglers. However, unlike a product in the supermarket, which has a price ticket on it, those recreational activities do not have a market value, which makes it hard to measure and for decision making. And my project is to use no-market valuation technique like travel cost approach with empirical data and state-of-the-art econometric models to evaluate one of the most important recreational activities in Australia, the recreational fishing. So the travel cost approach includes a lot of different types of models, but in general, they could be divided into 3 major groups. The participation model, where we model the number of trips to a particular fishing site as a function of travel cost and distance. The site choice models, where we model the probability to choose a fishing site among a group of others as a function of travel cost, site-specific characteristics, and individual-specific characteristics. And the third one is the joint model, where we model both the participation and the site choice in one model and in a consistent way. So later in the diagram, I will show you all major types of models depending on 4 dimensions. But before that, I'd like to show you this global map summarized based on my literature review, showing you the number of studies we found for each country and the proportion of the model types in each country. So in terms of the number of papers we found, we observed that US has the highest number of studies with about 64 papers, and then comes with countries like Mexico, Canada, New Zealand, Australia, and then UK, Finland with about 8 or 9 papers, and then countries like China, Brazil, South Africa with about 1 or 2 papers. And all those gray areas represent the countries with no papers found. And then in terms of the proportions, we found that most of the countries, they apply a single type of model, And to be more specific is the participation model. And then for countries like Australia and New Zealand, UK Airlines, and Portugal, they have both the participation model and the site choice model. And then for countries with high number of studies like America and Mexico, they have all three types of models. And then in this next slide, I'd like to show you that although the participation model is the most applied model in travel cost studies, there exists an ambiguity in terms of the terminologies in how to appropriately refer the model. So those are all different types of terms we found from papers abstract and title, showing you the same type, like refer to the same type of model, the travel cost model, or to be more specific, the count model. So we observed there are two major terms are used. The light blue area, the travel cost method with 12 papers, and then the dark blue area is the travel cost model with 24 papers. And then all other papers use the term like individual travel cost model, demand model, count model, travel cost, recreation demand model, but actually all those terms refer to the same thing, the count model, or to be more specific, the univariate count model. And then we also found two studies with one used the term multi-site demand model, and then the other used the term multi-site travel cost model. And those two papers refer the multivariate count model. So here is the diagram. I'd like to show you that we try to generate this classification of model types based on 4 dimensions. The first one is the focus. So like we just mentioned, you could focus on the participation or the site choice or both. In terms of the applications, you could apply it on a single site or multiple sites. And then in terms of the participation intensity, you could use the variable, the count variable, the continuous variable, or dichotomous variable, where only yes or no are used in the model. And then the econometric models here are the major models we listed here. So for example, for the participation models on the left side, it's usually applied on a single site. And then people use count variable to model the number of trips to a particular fishing site. So the models corresponding to this type is the count models. And then on the other side is the site choice models. It's usually applied on multi-site application. Usually we use the dichotomous variable, so only yes or no to a particular site is modeled. And then we usually use the discrete choice models. And then in the middle, we have the joint model group. So we just listed all the types of models here. But here I want to put a note here to distinguish 2 different choice processes by different colors, the red and purple. So the red represents the vertical choice process, which means that you make a single site selection at one time step, and then you repeat it at the second and third and go on. So that is why the models corresponding to this choice process are called repeated discrete choice models. And then the second one is the horizontal choice process, which means you make multiple sites selection all at once. And then you model those multiple sites simultaneously in your model. So that's why those models are called multiple discrete choice models. So overall in this diagram, we really just want to show you that here are the major models you could use to evaluate recreational fishery. And the aim here is really just try to disentangle the differences between models, so you know which model you could use depends on what kind of which dimension you want to focus. So for the next few slides, I'm going to briefly talk about some current issues that we have in the recreational fishery evaluation. The first one is about the choice set formation. So the challenges are 3 points. The first one is about the definitions. How to define the set, where to draw the boundaries. And the second point is what are you going to do if you have a manageable number of sites. And then the third one is about the choice set misspecification. So should we use the full choice set or individual specific choice set? Because usually in the survey, we only have the information of the full choice set. But then if we use the full choice set in the model, then we may add the computational burden by including lots of irrelevant sites. But then if we use individual-specific choice set, then the problem becomes how to appropriately define the individual-specific choice sets. So if it's not defined appropriately, then we may have estimation bias by excluding relevant sites. So some suggestions we found from the literature are, the first one is you could use the site aggregation if you have huge number of sites to aggregate them to form a smaller group of sites. And in terms of the individual-specific choice sets, you could use a specific criterion to define that individual choice set, such as use the travel cost or distance, or you could use stochastic selection process to randomly pick up the sites to form your individual choice sets. But then there is no conclusion yet which one is better. The second one is about the value of time. So the challenges are still 3 points. The first one is, should we include value of time or not as an opportunity cost in the model? The second one is, if yes, should we use the travel time or the leisure time or both? And the third one is, how could we measure them as the opportunity cost? So some suggestions we found is, the first one is you could use common hourly wage rate, such as minimum wage or a proportion of individual wage rates to all respondents. Or you could have individual-specific wage rates in your model, or you could ask individuals in the survey, saying that, are you willing to reduce your travel time or not? And then you only allocate that hourly wage rates to those individuals who answered yes. And the third issue is about alternative specific constants. So papers suggest that there exist some unobserved site characteristics that we need to consider in the model. But then how could we include those site-specific constants for each site in the model and for the estimation? So one approach they suggested is to use this two-stage approach, with the first step is to apply the discrete choice model to estimate a combined term of both observed and unobserved site characteristics, and then use ordinary least square regression to estimate this combined term, taking into account the unobserved site characteristic for coefficients estimation. The next issue is about multi-purpose and multi-destination trips. So usually once we have the data, there is a good proportion of data multi-destination or multi-activity trips. So the problem becomes, how could we allocate the travel costs across those multiple activities or across different sites? And then how could we determine the trip duration across those different trip components? So some solutions are, the first one is the simplest, it's just to ignore them. But then you risk of having estimation bias by excluding a good proportion of data. And then the second point is, you could ask in the survey, ask individuals, like, could you rank the relative importance of your trip activities or your sites, or record the travel time, like how much time you spend on each activity to decide this relative importance of the trip components, and then allocate your travel cost based on those relative importance. Or you could use the contingent behavior questions to identify those relative importance. And the last issue is about the catch rates. So should we use the expected catch rates or the actual catch rates? Because usually a paper suggests that there is a misalignment between the expected catch rates and the actual catch rates. Like what you expected to catch, how many fish you expected to catch in the next 12 months is not actually how many fish you actually caught, right? And then there exists some difference, the heterogeneity across individuals in terms of the catch rates. So how to capture those in your model? Some suggestions are, the first one is you could ask individuals in the survey, like, could you explicitly record your expected catch rates? Or you could just use the mean catch rates from the previous time period, or you could use the auxiliary regression, such as Poisson model, to estimate your individual specific catch rates, and then use those individual specific catch rates in the discrete choice models for the welfare analysis. So overall, all those issues I just mentioned, there's no conclusion yet which one is better. So I guess further studies need to be done in those areas. And if any of you who's interested in those topics or who's working in this field, I will be keen to have a chat with you after this talk. Or you could contact me, you could send me email. Here is my email address, and then we could organize some further chats. So like I said, this is a 3-year project, and I'm only in my first year. So once we have the data, we're going to try those different types of models and try to address those issues. Thank you very much.
Thank you so much to our speakers, and thank you all for being here. I want to invite the speakers up to take a seat, and then we'll be, if you have a question, raise your hand. We'll be passing around a microphone.
First question, thank you to everyone for presenting. That was a fantastic session. I really appreciate it. My question is to Harry. You talked about the fire retardant that we see on the news and everything. I've not seen it firsthand, thankfully. And we see enormous amounts of that dumped. What do we know about it, and what effect does that have to our waterways and the animals that live in them?
Thanks, Robbie, for that question. It's something that we're learning more about now. I had a wonderful conversation in the foyer last night with Matt Landos in regards to PFAS and how it breaks down. Over in Europe at the moment, they have been incinerating it. They've now stopped that practice because, yes, it breaks it down, but it breaks it down into 3 other unknown chemicals. So apparently Australia is racing away to start incinerating PFAS. So that's another conversation we had, but it definitely will remain in our waterways for a long time. I'm particularly using the Dairy Mountain site to see what that concentration, if it changes in PFAS, but yeah, it's a massive issue. And I mean, another good example is around in Newcastle, around the Williamtown area, near the RAF base, where it's been used for 30 years there. And the devastation it's done to those waterways there as well. Yeah, don't eat the crabs down there. That's correct.
I have loads of questions. So I think I'll start with Faith. For your work, super interested in thinking about once you've kind of established the risk and impacts of this, is there any work to try to think about moving towards identifying refuges that would be more resilient to these extreme events in the future?
Yeah, that's a great question. And with a lot of the mitigation or adaptation work, we'd be looking to collaborate with as many climate change adaptation and mitigation scientists, especially some of those people and groups who have worked in this field in freshwater ecosystems. There's definitely a want to look into that into the future, but we certainly haven't started it yet.
Break it up a little bit. Warren, it's an interesting concept that fish aren't fish, they're individuals, and that's something that came through from your talk. Can you define boldness? You may have said it, I might have missed it.
So boldness has been identified, well, I mean, if you use what the definition that Robert is using, Robert Arlinghouse, it's basically the likelihood of an individual to actually take the bait, so and in the context of fishing, but also the likelihood of an individual to explore, to be more active, and to, yeah, it's generally so when he's talking about boldness in particular in a recreational context, he's talking about some individuals are timid and won't take a bait, they're shy, and others will immediately just take a bait or a lure or whatever the case is. So that's, you know, sort of how he's. Sorry, what we're saying about it is that it's actually got a physiological basis. Yeah, exactly. So they see a lure and they make a decision on whether they're going to go for it or not. Some are more inclined to, and some are less inclined to, and I'm sure every angler knows that. I mean, very often you've thrown at a fish and it won't do anything. But it might, what we're trying to say is that at times it might be physiology that's determining that. It might be just outside the thermal range of that individual for activity, and that when it is inside the thermal range of that activity, it will be bold enough to go and take the lure. So there's a definite relationship between physiology and boldness, in our opinion anyway.
Yeah, my question is also for Warren, so I'll just follow up on that. I think your results were really compelling, and I think like looking at individual variation is definitely like the next frontier of understanding fish responses to climate change from a physiological perspective. But sometimes I'm not always like 100% convinced that aerobic scope is like the #1 best measure that we should be using, and I'm curious whether there's any plans or have already started looking at like survival of released fish, or like the ultimate fate of, are the fish you're referring to all getting harvested, or are some of them being released? And if they are, could we look at like survival? Because you'd assume some of these really robust fish are also better at surviving after they've been released, and if there's like a potential sort of mitigation opportunity there.
So the fishery itself is not generally a catch and release fishery. It's a boat-based fishery, and there's lots of barotrauma associated with it, and this species is very susceptible to barotrauma. So I don't think catch and release is a major component of the recreational, and certainly not the commercial. It's only mandatory release in terms of regulations. I agree with you on aerobic scope, and it's pretty contentious, but the one thing that I will say is that it was amazing how much our aerobic scope actually predicted activity in the wild. And the correlation between the physiological findings in terms of aerobic scope and activity in the wild, which were completely independent pieces of work, was really staggering, and suggested for us that for this species anyway, we're talking about a good metric to use. And I'm not saying it's necessarily going to be the case for other species. In terms of one thing that we do know about catch and release and post-release mortality, we do know that in warmer water conditions, post-release mortality generally tends to increase, and we know that already. And that's, I think, is a product of just the physiological incapacity of fish to actually respond well to stress on its upper thermal range. So that's probably the one other comment I can make.
I have a question for Hui about, you laid out a bunch of different issues, and I would be curious, I know you're at the beginning stages of your work, but I would be curious if you had an inclination about which of those issues may be most sensitive to climate drivers in your model, which influence maybe is of influencing angler decisions about travel and how that interacts with a climate signal.
Because like this abstract was submitted like 6 months ago, and then we kind of deviated. We did some investigations about the climate change, but then so far there is very limited study about evaluating recreational fishery under climate change scenarios. So there's not many papers found. So, but we have a good proportion of the kind of what type of model we can use in general to evaluate recreational fishery. And then in terms of the issues, I guess maybe the most related one would be, I would say that multi-purpose and multi-destination trips is a good one, because usually the climate change could influence people's behavior. Like sometimes like fish species random shifts. So sometimes when you go to a specific spot, you have your favorite fish, you're almost guaranteed to have your favorite fish. But then with climate change, you know that it's rare, and it's like the probability of getting your favorite fish is reduced, and then you might shift to a different fishing site. And yeah, like people's behavior, and then you might decrease your activities. And then, for example, if you visit 5 fishing sites in one trip, and then it might reduce to almost like 1 or 2 fishing sites, and then activities as well. Sometimes you could have both swimming, bushwalking, and fishing, but sometimes with climate change, maybe you just delete your fishing trips. You just do a walk, you just do a swimming. So yeah, I guess that's one. And then for me, I think in general, the most promising issues I'm going to address is, first is about the value of time. So there is a great proportion of studies trying to consider the value of time as the opportunity cost in the model. Because usually people don't record how much time you spent on the activity and how much time you spent in travel, and they don't really care about this kind of opportunity. But actually this is quite important, because sometimes leisure time is important for them, and then the travel time is important, but sometimes it's different. Like some people just prefer traveling, like they prefer just to stay in the car and drive along, while sometimes just try to reduce their travel time. So there's heterogeneities across individuals, but also there's an argument between, like, should we use only the transit time, like time in the transit, or the leisure time you spend on the site? So yeah, lots of interesting points I'm going to explore. So yeah, again, if there's anyone who's interested, I'm happy to have a chat.
Well, questions for you again, because I think that qualifying the economic value of fisheries is hugely important in the space of money for fisheries. Like, we have to be able to, that's the golden ticket when you're arguing, is putting that value on it to submit to governments. What I noticed, though, you said at the end there you were going to put a value on catch, or value on each fish caught. Is that
The catch rates?
Yes, yep. So, whereas I was wondering how that would really, whether that's as valuable as it should be, because when a lot of fishers actually value time fishing more than fish caught. So I'm happy to go fishing all day and catch one rather than, it doesn't matter how many fish I catch.
Yeah,
it's
so
the experience.
Yeah, exactly. So that's another interesting topic. I haven't mentioned it here, but it's kind of related with the catch rates. So like different values refer to if you value the experience, or you value how many fish or what's the species you actually caught. So there's different types of different values that you could put, but unfortunately, I think in the survey we don't have any data about it. Like we don't have specific question asking people like, are you still feel happy if you got no harvest at all? Or like, what's your satisfactory, like what's your point of satisfactory? Like, are you like 100% satisfied if there's no fish caught? Or like if there's no fish caught, you reduce from 100 to 80%, something like that. So once we have the data, that would be an interesting point. So that's why most of the issues I put here, most of them related with the survey design. So hopefully we could be involved in the process, or maybe someone working in the government could be involved in this project. Like maybe we could have more sections asking individuals about like travel time and your experience, value of your experience, or the catch rates, or lots of things.
Can I just comment on that? And it's a really good answer to that question, and I think increasingly there's more and more scope with some of the wash-up surveys that come at the end, or the attitudinal surveys that come at the end of the catch and effort surveys that each jurisdiction's running, for questions to be asked about either the motivation or the value of a individual fishing trip, irrespective of whether or not an angler caught anything. So there's definitely scope for that. And I also wonder whether or not Andy Moore's national survey sort of touched on that type of valuation, irrespective of catch.
Thank you.
Okay, and I just had one other question, which was for Ozfish. I remember 2019, I was sick at the time, and I was laying in hospital, and I watched the whole thing unfold on ABC News 24 hours a day, and it was heartbreaking watching all those caught at Menindee and what had happened. And I know she spoke about putting aerators in at the time, and I just wanted to know how effective were they, because I remember sitting there watching that thinking, they don't have a hope in hell. But how did you go with that?
Yeah, look, thank you. Good question. And definitely the aerators did help, but they were not that effective. They're effective in a small area because these are solar operated. And we need to sort of come up with better ways for aeration for those larger pools. But they did have, they did work, probably not as efficiently as we wanted them to. The reason why we had such a big fish kill in Tennantfield was because they turned the aerators off. So yeah, they're great in a small area, but yeah, we really do need to work. And I mean, just recently we had to go and get them out too because of the floods. So.
Yeah, look, I concur. It's absolutely a last resort aeration. It was desperate measures. And we knew that in those pools with diving oxygen and low dissolved oxygen that, making a bit of difference was going to make some difference at least to the fish that were there. And it was all about creating those refuges. So we basically created these little oxygen refuges, and we found that the fish moved into them even if we weren't putting them on those. So, they were making that little bit of difference to the fish that were near there, but as I say, desperate times, desperate measures.
Wonderful. Thank you so much. Are there any additional questions from the audience? Yeah?
Yeah, I also for Ozfish too. I've heard about this story a few times in different talks, and it's like absolutely mind-blowing story of like people going in and like physically moving fish to a different environment. It obviously had a massive impact on everyone who was involved, and on me, like listening to the story. It's really amazing. And I'm curious whether you have any idea of the ultimate, what happened to those fish once they were put in, how many of them survived? Did you find some of them dead later? Have you done genetic studies to see if they're all that?
Yeah, good question. It's early days.
Yeah, look, that is a good question. Early days. So majority of the, so we'll go back to 2009 and 2020. The fish caught up in my end of the world were taken to refuge holes within Tennantfield Creek and the Jimerick River. So they were relocated into those zones. That's right, back in, literally still in the same system. But the fish rescued from the Bidgie and the Barker and that they were taken to Narrandera with those genetics. Some kept at the hatchery for different stocks, but majority of those fish were returned back to their original waterways. So, and that's the...
So the ideas of putting them in there, in deeper holes as their little hole dried up, they couldn't swim to the next one, was that once the water came back up again, then they were there, they were ready to repopulate that area. So that was our sort of ultimate thing that we wanted to do, was keep them in their own river. And so those fish were there and available when the river was healthy again.
Wonderful. Thank you all so much. Thank you so much to our speakers, our panel, and for a wonderful climate change session today.